In this section, we talk about finding and using the slope to help us determine if lines are parallel or if lines are perpendicular. So the learning target here, I can calculate slope and I can use slope to determine if lines are parallel or perpendicular. So what is slope again? Just to refresh what slope is. It's the steepness or the incline of a line or a road. So when we, back in algebra, we did a lot with slope and we determined what was the steepness of a line. Well, to figure out the steepness of a line, we can take a look at the graph and we can calculate its rise and its run. Or we can take a look at coordinates, because when you take a look at that graph and you calculate the line's rise and you calculate the line's run, all you're really doing is just figuring out what is the vertical distance, or what is the difference of your y's. That's what that vertical distance is. It's the difference of your y's. And then what's the horizontal distance? The horizontal distance is the difference of your x's. So that's what's shown right there. So we can calculate the slope by either just looking at the graph and figuring out the rise and the run, or by taking two coordinates and figuring out the difference of the y's over the difference of the x's. And now with that slope, you worked a lot with slope-intercept form last year in algebra, and the slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So find the slope of this line. Looking at this line, there's two different ways that I could specifically identify it. Let's just use the way of finding rise and run by looking at the graph. So when I look at this graph, I need to identify two specific points. So go through the line and identify two precise points where it crosses, so you can calculate and figure out what is the rise and what is the run. All right, so it looks like those 2 points right there. It crosses right here at 1, 1. And it crosses up here at 6, 4. So I can calculate it by taking y2 minus y1 over x2 minus x1, or I can specifically look at the rise and the run. So the rise here would be this distance, and I could have picked any two coordinates on this line. The only reason I picked those two is because I could specifically see what their coordinates were. So the rise here would be 1, 2, 3. So our slope would be 3 over whatever the run is. The run is the horizontal distance. So 1, 2, 3, 4, 5. The slope of this line is 3/5. All right, so that's how you can just look at a graph and find the rise and the run. Or to also calculate this rise, what we could have done is subtracted the y's, 4 minus 1. And then to figure out what this horizontal distance is, we can subtract the x's, 6 minus 1. And then you come out with the exact same slope, 3/5. All right, so slope is going to be positive anytime your line rises to the right. So as your line increases, that means you're going to have a positive slope. Whenever your line kind of drops off, or as it falls to the right, that means you're going to have a negative slope. So on this previous slide, our line increased as we moved to the right, and then if your line decreases as you move to the right, so if your line goes downward, that means you're going to have a negative slope. A slope of 0 means that you have a horizontal line. So it's a perfect horizontal line, and you will always have a slope of 0. That means it has 0 steepness. It's like walking down the hallway. When you walk down the hallway, there's 0 steepness to that hallway. But if a line is straight up and down, a line that's straight up and down, you can't have steepness. You can't really identify the steepness of something that is straight up and down. So since you can't identify the steepness of that line, we say that the slope is undefined. The slope is I guess, undefined. You can't calculate it out. And that's because you can't divide by 0. 5 divided by 0 is undefined. So a vertical line will always have an undefined slope. So find the slope of each pair, or each line, and then determine which two lines are parallel to each other. We can look at these lines and we can say, you know what, I think C and B are parallel to each other. And the reason is, it's because they have the exact same steepness. Well, if they have the exact same steepness, that means we can prove. We can prove that these two lines are parallel to each other by finding their slope. So let's take a look at the slope of each one of these lines. The slope of this first line right here. Take a look at your rise and your run. Our rise, taking a look at these two coordinates, our rise is a -1, and our run. Because I started at this coordinate and went to this coordinate, my rise was a -1. My run is in a positive direction, so my run would be 1, 2, 3, 4. So your slope is -1/4. Now if we take a look at the next line, for line B, our slope, so I'm going to go from the left coordinate to the right coordinate. The slope is down 1, and we are going in a positive direction, 1, 2, 3. And then if we take a look at the slope of the last line, I'm going to go from the right coordinate to the left coordinate this time. So if I go from the right coordinate to the left coordinate, I am going up 1, I'm going a +1, and I'm going to the left 1, 2, 3. So that would be a -3. So now looking at these slopes, analyzing these slopes, the top one was -1/4. The second one is -1/3. The third one is -1/3. I can draw a conclusion about this now. I can state that B and C are parallel to each other. Line B is parallel to line C. And I know this for a fact because I just showed that they have the exact same steepness. So two lines that have the exact same steepness I know are going to be parallel to each other. So parallel lines have the same slope. Find the slope of the two lines that go through the following points. So this here is line 1, and I'm going to take line 1 and I'm going to subtract the y's. Remember, it's y2 minus y1. So I'm going to subtract the y's, so 6 minus 3, and then I'm going to subtract the x's. 2 minus 6. 6 minus 3 is 3. 2 minus 6 is -4. So your slope is -3/4. Now if I go to line 2, subtract your y's, and then subtract your x's. 3 minus 7 is -4. 1 minus 4 is -3. So this would be a +4/3. Now if we take a look at these two lines, these two lines right here have opposite reciprocals for steepness. So when I say opposite, that means one is negative and one is positive. And then when I say reciprocals, that means one is 3/4. And then if I take that and flip it, the numerator becomes the denominator. The denominator becomes the numerator. So if I take this fraction and I flip it, I get 4/3. So these two lines have opposite reciprocal steepness. And what that means is your two lines are going to end up being perpendicular to each other. Whenever you have slopes that are opposite reciprocals, it means that the two lines are perpendicular. So perpendicular lines have slopes that are opposite reciprocals. So are these parallel, perpendicular, or neither? Well, we can prove this by simply taking the coordinates and calculating their slope. So find the difference of the y's, 4 minus 1 over -3 minus 3. This would become 3 over -6, which is -1/2. And then these here, difference of the y's, 1 minus a -7 over 6 minus 2, So 1 minus a negative 7 would be 8. 6 minus 2 would be 4. This is a positive 2. So these two right here are opposite reciprocals. One is negative, one is positive, and then reciprocals, this is a half. If I flip that, I get 2 over 1, which is 2. So since these are opposite reciprocals, I know for a fact that these two lines are perpendicular to each other. All right, so the practice for today, take a look at the practice worksheet, and that one goes through quite a bit dealing with calculating slopes. And then after you calculate slopes, then it goes through a fair amount determining if those are parallel or perpendicular to each other.